Okay, hello everyone. This is Dr. Holroyd here, and as part of this course, what we're going to do is try and give you a few introductory videos relating the material you're covering to physics, to the neuroscience and physiology you'll do later on in the course. So this week, or this coming week in physics, you're going to be looking at waves and types of waves and how they relate to sound. Now you're going to learn about different types of waves. You have transverse waves. And in a transverse wave, what happens is the particles within the wave, so the wave is moving in this direction, the particles move perpendicular to the wave. And this is something that happens, say for example, if you're holding a rope and your friend's holding the other end of the rope and you wiggle it and the rope sort of goes like this. So the direction of the energy movement is in that direction, but the particles are actually moving backwards and forwards, so a transverse wave. With regard to sound, a transverse wave isn't very important because with sound waves what you have is they utilise longitudinal waves. And in a longitudinal waves what happens is that the particles move in the same direction as the wave. So a longitudinal wave is what we're interested in. So we'll come back to this in a minute and how sound is a longitudinal wave. So before we go on, I just want you to look here at the diagram on the right. So before we talk about sound, just to make sure you got a good idea of the movement of the particles in a longitudinal wave. As you can see here, the diagram or the GIF on your right shows the movement of a particle in red. So notice that the particles move in the direction of the wave, however they don't move along the whole wave. They move backwards and forwards, they vibrate. But by moving backwards and forwards, they push the particle next to them and move that along. So it's important to note the particle moves in the same direction as the wave, but it doesn't move the whole length of the wave, it vibrates backwards and forwards. Now we can go on to sound. Let's just look at sound itself. And sound is a mechanical wave, we call it mechanical wave. And what it means, or what we mean by mechanical, is that it needs a medium. So it needs a medium which it disturbs the particles within that medium, and by disturbing the particles it makes the wave. So you have to think a little bit about what sound is. Let's think about the easiest thing is when you talk. So when you talk you produce a sound, but how does that sound occur? Well, what happens is when you talk you have your vocal cords, and the vocal cords vibrate. So what they do is they move this way, that way, backwards and forwards in these directions. And by doing that, what the vocal cords do is they push air particles. So for example, if they're moving in this direction, they'll push the air particles closer together. When they move in the opposite direction, so when they move in this direction, they're going to pull the air particles further apart. So if they're vibrating at a certain frequency, pushing in one direction and recoiling back, pushing again, recoiling back, and so on, you're going to get a series of areas where the air particles are far apart and where they are close together. Where the air particles are far apart, it's called a rarefaction, and where they're pushed close together, it's called a compression. And so you can see that the movement of the particles is in this direction, and this is a wave, it's moving in this direction. So you have the classic longitudinal wave. So it's longitudinal. I apologise for my very bad writing. So we have a longitudinal wave, and the wavelength is from the beginning of a rarefaction to the beginning of the next rarefaction. Alright, so here we have the longitudinal wave. The particles push against each other to produce the compressions and then pull apart in order to produce the rarefication. So that's all fine and good, but how do you actually hear? So someone's talking, so let's have a look at this person here. There's their eye, very bad, and they're talking, and so the sound wave is coming out. And then here is someone's ear, and they're listening, and what happens is the sound waves moves into the ear and hits the eardrum. Now, when you think about this, what we have is we have a sound wave which is made up of these compressions where the air particles are close together, and the rarefications where the air particles are farther apart. Now, when the compression hits the eardrum, it's going to force it in this direction because the air particles are pushed close together, so they're going to force it in this way. But then once the compression has passed and the rarefication hits, you're no longer going to have that same force pushing it in this direction, so the eardrum will move back in this direction. Then when the next compression comes, it will force it in this direction, and then when the next rarefication comes, it will move back in this direction. So what will happen is that the eardrum will vibrate, move backwards and forwards. And the frequency, which is 1 over the wavelength, the frequency will be directly related to this wavelength that is hitting it via the sound. So hopefully from looking at this or seeing this very quick video, you'll get an understanding of why it's important to understand longitudinal waves. Later on, you'll look at transverse waves, and they're important for other things. And by understanding how a longitudinal wave works, will give you a better understanding of why your vocal cords need to vibrate, how this produces a wave that you can then produce an action on the eardrum. And in neuroscience, and also in some of the physics that you do in this coming week, you'll learn how the vibrating of the eardrum, so when the eardrum vibrates, what happens is that is amplified by the middle ear, and then it reaches the inner ear. And in the inner ear, the frequency of the sound is then coded and processed by the brain, so you can actually hear what the person is saying. Now, probably a lot of what I've said might not make too much sense at the moment, but as you go through this week in physics, and Dr. Yusuf talks about waves and sound and the process of the vibration in the eardrum and so on, you'll have a better understanding of how that relates to physiology, neuroscience, and the process by which we hear.